So I have extended the due dates of this week's exercises by 1 week. As you can see, this is the lesson 7 supposed to be due on this weekend on 8th, but I extended it to 15th. 15th, and for the packet tracer I am giving you 1 week extra, so it is on 22nd. The packet tracer goes all the way to 22nd, so you have more time to complete the packet tracer exercise too. Okay, all right, so today's chapter is on network architecture. What we have studied so far, if you remember, or if I take you few weeks ago what we did or in the past lessons. So we started with a simple introduction to networking. We talked about infrastructure and documentation, which was a simple chapter. Then addressing was the one important chapter we did, where we discussed about the IP addressing, right? What are the different versions of IP addressing we have? Anyone remember? 4 and 6. How many parts are there in version 4? How many sections or parts in IP address in version 4?
32.
4 parts. 4 parts in IP address. But there are 2 types of addresses in IPv4. What we call them? Two types of addresses.
Public and private.
Huh?
Public, private.
Public, private. Right? Public, private. And every IP address has 2 information. Every IP address has 2 information. If I am writing 192.168.1.1/24, what does it mean?
24 is telling you how many computers there is.
How many?
How many computers it is.
Okay.
How many somethings. Yeah, I think it's how many computers, right? It's like, that means divided by
24, 20, if it is 24, then does it mean 24 computers?
There's 3, I think, right?
3 computers?
I believe it was the third octet.
Sorry?
You're gonna look for our addresses up to your third octet.
What this number represents?
How many networks?
How many networks? This number is actually represents
How many bits?
3 octets. This number represents 3 octets. I posted one video link and nobody watched that video. This is the 3 octet. This represents 3 octet, and it is network, it is host. This 24 means 3 octet represents network and last octet represents host. Is that clear?
Yes.
Yeah.
And if I say 16, what does it mean?
2 optic.
2 octet.
2 octet represents network and 2 octet represents
Host.
host. So if I have 2 octet representing host, how many hosts we can have? 16, 2. How many hosts we can have?
If you have 2 octet?
2 octets? Yeah, 2 octets representing hosts. So how many total hosts we have or we can have?
255 per octet?
255 per octet. So 2 octets representing hosts. So how many hosts? 255 per octet means 255 plus 255?
Yeah.
That's why it is very important for you to study everything from beginning. If you are not making your base strong in this class, then you're gonna face problems in other classes. You won't be able to understand what's going on. Okay? So please learn. Please spend some time with your books, with your chapters. Alright? Don't just, and I know, and you all know that AI can do many things, but when you go for an interview and they ask questions, then AI not gonna answer those questions on your behalf. You have to answer yourself. So we discussed, and I posted this link here in the additional learning, CIDR notation and subnetting. Please, if you have time or you are serious, then please watch that video. So IP addressing, then we discussed about protocols. So what type of network models we have? There are two main network models we have. What are those? There are two main network models we have. What are those? And so one is OSI layer model, another one is TCP/IP model. So if you do not remember the name, then how would you remember the number of layers those models have? Okay. What type of cables we have?
Yeah, twisted pair.
Twisted pair.
Coaxial.
RJ45 is not a cable, it is a connector.
Just coaxial.
Coaxial,
Fiber optic.
fiber optic, twisted pair, and there are two types of twisted pair. What are those?
Shielded or not shielded.
Shielded and unshielded. Now in the twisted pair we have some categories. Remember? So only one person remembers everything? Others are.
It's UTP and STP.
I'm asking about categories. So UTP and STP he already answered. Unshielded twisted pair and shielded twisted pair. Now I'm asking about how many categories you remember. You don't answer.
Cat 5 to 8.
Cat 5, Cat 5e, Cat 6, Cat 6a, Cat 7, Cat 8. Please study. Okay? This is not gonna help me. It's all for you. Alright, so today we are going to talk about the network architecture. Let me bring this slide on the screen and here is the slide. In this network architecture, we are going to discuss few things. How to build a network. When we are building a network, what's your name? Kaduz. Is it your first day today in the class? You're regular? Oh, sorry. Sorry if I missed you before. That's okay. Okay. So we are going to look at the following objectives in this lesson today. We are going to talk about how to configure and manage switches in physical network architecture. What type of switches are there? So remember last week we were talking about switches, or before we have dumb switches and we have smart switches. How many of you remember the domains? Broadcast domain? Remember anything? Broadcast domain and collision domain?
Collision.
Right? So broadcast domain, your hubs, your dumb switches create broadcast domains and your smart switches creates collision domains. And if I talk about one-to-one communication, so which type of switch out of those two supports one-to-one communication? Broadcast or collision? Collision. Its collision domain switches or smart switches supports one-to-one communication, or in other words, there are other things we have like switch security. Which type of switch supports security? And it is your smart switch, or the collision domain switches support security. So we'll talk about the forms of virtualization technologies we can use in a network, summarize of cloud architecture. So few topics we may cover next week. Most of these we will cover this week only. We may do this lesson in two parts. Types of switches. So remember we have two types of switches always. One is called unmanaged switches. Provides plug and play capability with minimal configuration option and has no IP addresses assigned to it. So these type of switches are generally categorized or known as hubs or hub switches, which are like treated as dumb switches. So these type of switches, they are just like you just bring the switch, connect all the cables of computers together, and all the computers are connected with each other. But in these type of switches, remember one thing, that if this is my switch and the computers are connected to this switch, then one computer, let's say this computer wants to send some signal or some message to this computer here, but this switch, what the switch will do? Switch will send the signal to all the computers in the hub. And then computer themselves or itself decide whether this signal is for me, then it will accept, otherwise it will reject. So these computers are not smart enough to understand if this message is for me or for someone else. For example, if I call someone's name in this class, I say Nigel. So Nigel is listening to me, but you all are also listening, but you are not responding. Only Nigel is responding because the messages are for him only. So it is something like your computers are receiving the messages, but they are rejecting. Only one computer is accepting because it is, the address is given in the message of that computer. So this computer, the message only has the address of this computer. That's why this computer receives the message, respond for the messages, but other computers also receiving the message. However, because the destination address does not match, that's why they reject those messages. So your physical layer and the data link layer works at this level, where they receive the message, but data link layer identifies, oh, this message is not for me, reject. However, in the managed switches, these can be configured via a command line interface, or now we can also use a web interface. A web interface which you can open on a browser. So it's a kind of GUI, which is some administrators does not prefer using GUI. Most of them still like command line, because command line gives you more flexibility, it gives you more control power on your devices. Plus you can do lots of programming. You can create your small programs or scripts, we call them scripts. You can create scripts and you can execute those scripts to do certain tasks in a single shot. So managed switches are smart switches. They are creating collision domains. They also has an option to assign an IP address. They provide a console port to you, and using that console port you can connect those switches to your laptop or to a management network. Now these switches are basically considered as layer 2 devices. However, the higher layer switches also exist. When I say layer 2, which layer is this? Anybody remembers? Data link layer, right? Data link layer. However, we have other higher layer switches also exist, and those higher layer switches can give you more functionality, such as they can give you switch port security, they can give you even firewall function, or firewall functionality is kind of embedded in the switches, and sometimes switches can also doubled up as a router. So if you remember your home router can work as a switch as well as a router. So both the things are there, both the options, even the firewall is there in these home routers. So those are the layer 4. So you have all these capabilities available in these switches now. So switch port security is one of the main functionality we can enable in our smart or managed switches. And what is the switch port security? What it does basically, it blocks your or reserve your ports in the switches for a particular MAC address. Now what is MAC address? Anybody?
MAC address is like a
Physical address.
number
Physical address of
of it, like a device, like a network interface card.
network interface card. MAC address is a physical address of network interface card. So if I say this is my switch and this is the port where the computer can connect, if I say only this MAC address can connect to this port, so any computer because every computer has a unique MAC address, so if other computer connects to this port, it cannot communicate, because the MAC address of that computer does not matches with the MAC address reserved on this port. The MAC address reserved on the port is double A, whereas the MAC address of the connected device is double B, so they both cannot talk to each other. So this type of security we can enable on our switches with the help of switch port security, and that gives an additional layer to your network security. It disables the switch ports that can be indicated by the following statuses, such as administratively down, error disabled, or suspended. Means you can block your switch ports as well. Let's say some ports are not in use. Some ports are not in use in your switches, so you can block those ports so that no one can use it intentionally or unintentionally. You can disable a port on Cisco and Arista routers as well and switches with the shutdown command, and you can enable them back with the help of no shutdown command, so which is like opposite to each other, toggle command. So these type of commands are known as toggle command. You can use shutdown to disable the port, and you can use no shut to enable the port again. So with the help of these two commands, so you can try these commands, and if you do the network these packet tracer exercises regularly, or you watch their videos. Now there are certain videos only in packet tracer. You can see some videos are there. Last week we saw one video, but if you do not replicate the same in the packet tracer, you will not learn anything. So it is my, I cannot make it compulsory, but it is my suggestion to all of you that whenever you watch a video on packet tracer, try to replicate the same in the packet tracer application. If you won't do that, then you won't learn anything. So take my advice seriously. So if you go to the interface of the switch, so first of all, what you will do, you will connect the switch, then you will open the config of the switch. First of all, you enable it, then you go to config, then you go to the port by using interface command. Interface, and which interface you would like to go to, and then you execute these type of commands, either shutdown or no shutdown. You can learn this part, in the packet tracer video of the previous lesson. So go to the lesson number 6, and there you can see the packet tracer video where you can learn how to get into the switch and how to execute commands on those switches. So you can do that packet switch port security. This is simple concept of disabling, enabling of switch ports. So here you are not binding your port to any MAC address, you are just disabled it, because so that no one else can use it. Now if you want to enable or you want to associate your port with some particular MAC address, then you will say switch port security. Switch port followed by port security. That is a simple command, 2-word command, switch port followed by port security. And in that case, whichever MAC is connected to that switch at that moment will be reserved for that port. This is a MAC filtering function that protects against MAC flooding, and the MAC table allows one MAC address per port. So this type of switch port security is only one layer of defense, which is basically protecting your network from any kind of unauthorized access. But remember, this unauthorized access only possible when someone can walks into your data center or your network center and connect their networking device physically to that switch. So in order to reach to that network device, the person has to pass another physical layer or other physical layers of security. He has to enter the premises, he has to enter the building, he has to enter the room, he can, or he should be able to open the rack, then only the person can access that device, isn't it? But there are other methods also with the help of which they can do this remotely, and they can spoof their MAC addresses and use some existing connections in your network to connect to your device. So there is difference in depth. This concept of protecting your network or protecting your devices from physical access is anyone can or should not be able to access the devices physically. That the concept of that security is known as defense in depth. So if this is your device, so this device is located inside a rack, this rack is in a room, that room is in a building, that building is in a premises, and every layer is protected. Every layer is protected by different means, right? So this is your premises, the entry from here, then entry to the building, entry to the room, entry to the rack, then only one can access the device. So this level of security is known as, or this strategy is known as defense in depth. And data center, in the data centers we talk about this concept. Okay. So now the switch path management, these are the various concepts we have. So redundancy allows, so now when you are doing your switch path or you are building a path for any particular device to communicate over the network, we always use multiple switches in the network, and that introduces the redundancy. Redundancy is like I need to create multiple paths so that, listen, we should understand one concept here which is known as single point of failure. Single point of failure. And in the IT industry, in order to ensure the service reliability, service availability, we must remove single point of failure from our network. And it starts, so what is the purpose? Purpose is to ensure the service must be up and running. The target is service must be up and running. Now, service is running where? So if I ask you, service is running where? So service always runs on server. Service always runs on server. If the server is single, so it may fail any time and your service can go down. So what you do to protect the server from becoming a single point of failure, you use dual or two servers connected to each other and making something called cluster. Making something called cluster, or we can also use, these days we are using virtualization. In the virtualization, the servers are running virtually. Servers are running virtually on a virtualization platform like VMware or Hyper-V. In that case, the virtualization platforms are capable of protecting the servers from any failure. They always have a standby available. So we have this type of arrangement. Then comes to the data, where the data goes. Does the data stores with the server or data goes outside? So we are using some external storage devices, and those storage devices also has built-in mechanism to protect your data from failure. So that is, we are avoiding the single point of failure. Then comes the network. And in the network also we need to provide or protect our network from becoming a single point of failure. In the server itself, you are using multiple NICs. Multiple NICs you are using so that you can connect your servers to multiple switches. Multiple switches. Their servers are using multiple NICs so that you can connect them to multiple switches, and then it connects to the backbone switches like this, and then they are connected to the router, and all that type of network is created. Now, when you are using this kind of a structure, then you must understand that which network path. Now, if I ask you how many paths this server has to exit from this network, how many paths this server, so you can go from this, this, or you can go from this to up, not here, this, might be they are connected this way, so this. So if you start counting, then you will find there are multiple paths exist for the same device. So this type of redundancy we create in our network. And this spanning tree protocol, or STP, which is always there in these smart switches or smart networking devices, this spanning tree protocol prevents traffic loops. Means your data will not come back to you on itself, to you only, and also called switching loop, by calculating paths that avoid potential loop, and by artificially blocking the links that would complete a loop. So it will not give your data back to yourself. It will not give your data back to yourself, and it always prevents those type of loops to form, and your data can transmit successfully. So STP chooses the most efficient path and calls these least cost path, LCP. So it will always try to find a path which will, now what is the cost here? So if you go into the details, where generally we discuss this in network engineering classes, every network connection has a cost, and that cost is not calculated in terms of dollars or money. This cost is calculated in terms of performance. What is the performance of each path you are using? And based on the least cost path, it finds one path which is preferred path. It's not like that this will be the only path it uses, but it will be the preferred path. For example, if you want to from one place to another place, and you are using GPS, so what the GPS tries to do? GPS tries to give you 2-3 paths, but one path is always selected. So that is your preferred path, but there are other paths also available which you can choose. So same is here. So it is using a least cost path by default, but it also has other paths available in case that least cost path is obstructed because of some reason. Then it will start using the other paths available in the network. So this type of switch path management happens in these smart switches. And if you look at this diagram carefully, there you will see a lot of switches and devices. So these are the servers. We have a switch A, we have a switch B, switch C, switch D. Switch B and D are the middle switches. Switch A and C are the edge switches. These are the edge switches because they are used for connecting the end devices. These are edge switches because used to connect the end devices. These are your you can say backbone switches or the middle switches, which are used to connect the networks or multiple switches together. Now here the DP indicates the downstream and the RP indicates the upstream port. So RP is upstream, DP is downstream. So from here to here and here to here, it's always from A to D is RP and D to A is DP. Same as here, switch to D, or C to D is RP, but D to C is DP. So it is created network like that. But if A and B RP DP is blocked for some reason, then it will automatically use this path from A to D to C and so on. So switches are themselves calculates the cost and finds a proper path. Yes.
Why is the why does a certain switch end up being the root, or like how or why does you end up deciding which one's the root?
Which one is the
Is the root?
root?
Yeah.
What do you mean by root?
It says, or I mean, when I was looking up the tree STP thing, it says like it picks the shortest path to the root, but who's the root, or why is there a certain
Okay.
root?
So who's the root is basically identifies if your device, if your switches are connected directly to the communicating device, which is your computer, printer, or these kind of access points. Those are always preferred as edge switches. Okay, so those are edge switches, and next is your kind of level 2 switches. But after those switches, we are having that concept in the coming slide also. But after those switches which are connecting to the maybe router, let's say, or to the firewall, those switches are generally considered as the root switches, which are basically connecting whole of the network to the final destination, which is your gateway or the router where your data travels to the outside of the network. Okay. Now, what the STP is doing, or the switch path in the switch path management, so STP information is transmitted between the switches via a protocol which is protocol data units, which stands for BPDU, or you can call it bridge protocol data units. It's a kind of information which your switches are kind of exchanging with each other. For example, in the previous network, if you see this switch A, D, C, B, they all are in the same network, but they keep on sharing the information of the connected devices with each other. So switch A is kind of sharing that information, like what devices connected to switch A with D and B. So D and B knows that what devices are connected to A. Same as D and B also knows what devices are connected to C. Okay, so this is a path, or this is the information they are sharing with each other, so that whenever you are trying to communicate, or you are sending a signal to let's say this computer here, sending some signal to this computer here, so switch A is passing that information to switch D, because switch D knows that this device or this IP address belongs to switch C. So it automatically sends that signal to switch C, and then it reaches to the particular destination. So they are sharing that information with each other with the help of this BPDU. Switch ports exist in one of the 5 STP port state, and that you can check with the help of switch port state command. So either the switches are blocking, means the switch port is not enabled. Either the switch port is listening, means it is open. It is learning, means it is trying to recall or remembering what is on the other side of it. Forwarding. Some of the switch ports are used for connecting the switches to switches. So switch to switch connectivity is generally known as, or it is classified as forwarding port, because the role of these type of ports is just to forward the data traffic from one switch to other switch. They are not communicating to any of the node device. And finally, it can be a disabled port. Okay, so these are few states you can see when you look at the command, or you check the status of your switch ports. So you may see one of these states in those ports. There are various newer technologies to improve or replace the STP. So STP is a kind of a very old technology, but still very relevant. But there are some new technologies available, such as RSTP, or Rapid Spanning Tree Protocol, transparent interconnection of lots and links, which is TRIL, SPB, shortest path bridging, and some switch manufacturers have designed proprietary versions of STP. So for example, you learn Cisco. So Cisco will have its own STP version. If you learn, let's say Juniper, so it has its own STP version, or Broadcom has its own STP version. Now, most of these switches or devices support similar set of commands, but you may find some of the commands different that you may need to learn based on which manufacturer's switch you are working. And every switch company or every switch vendor has their own list of certifications. So you can do Cisco certification, you can do Broadcom or Juniper certifications wherever you would like to go for it. But learning of one type of device enables you to learn other type of device by yourself. You don't need to go for classes for a different device. So it is something like, if you know how to use one type of Linux, let's say you know how to use Red Hat or how to work on Ubuntu Linux, so you can always work on CentOS, you can always work on Red Hat by learning few additional commands, by looking at a different interface. You can always learn by yourself. You know how to drive Nissan car, then you know how you can figure out how to drive Toyota or Mercedes or BMW. That doesn't matter. A few moments of study, and then you are capable of operating any other device of similar type but a different manufacturer. Now, we always follow this hierarchical design of network, and either Cisco or other manufacturer, they have developed a design for switches in a network called three-tiered architecture. Three-tiered architecture, and what are those tiers? So the access layer, that is the very first layer, or you call it edge layer. It consists of work group switches connected directly to host. Now you should also remember that whenever you are talking about network, then what is host means, or what is the meaning of node. Okay, so there is a big difference between host and a node. So host is the end user communicating device. It can be your server, it can be your workstation, it can be your printer, it can be so any of these. Now, what is node? Node is any device which can communicate over network. Which can communicate over network. So think about devices which can communicate over network. So any host can be a node, any switch can be a node, any router can be a node, any wireless access point can be a node, any printer can be a node. So it can be a node. So there is a big difference between a node and a host. Okay. So if you say, can a switch be a host? No. So remember those things. So this differentiation is very much important, because when you read these kind of text and you do not understand the difference between the host and the node, then you may get confused.
Can one device be both, or is only one or the other at a time?
Okay. So your host is a node.
Okay, so host is always a node?
Host is always a node. Okay, so access layer or the edge layer. So now if I say this is my PC and this is a switch, this is a switch, sorry. So what type of switch is this? Access or edge switch, because it is connected directly to the host. Next come to the distribution layer or the aggregation layer, and it is a highly redundant mesh of connections between multi-layer switches or routers. So this is the device, or this is a type of switches which are providing you a redundancy for the network, and they are creating a mesh topology with each other. So this switch, there can be multiple two switches, and they are providing you this type of connections. So they are connected to this switch. So every possible connection should be there in those switches or in those devices, whether it's a switch or a router. And finally is a core layer, which consists of highly efficient multi-layer switches or router that supports the network's backbone. And after this, you have a switch here, switch here. Now they are also connected this way, but there is a distinction. There is a distinction between the distribution layer and the core layer. Is in the distribution layer, the switches are connected to each other, but in the core layer, switches never connects to each other. They connects to the other switches, but they never connects to each other. Yes.
Is this one, the switches in this room, are these distribution layer? Or are they, I guess, are they distribution layer?
Good question. Just think, what are they? Are they connected to another switches, or they are connected to directly host?
I mean, this is what we connect to, right? So this
Yes.
is distribution.
This is we connect. So which switch allows us to connect to the host?
Oh, is it access layer?
Yeah.
Okay, so this is access, so where's the distribution layer one? Is that
Distribution
not-
layer somewhere, maybe in this building or maybe in the building A.
So where's the core one then?
Core one definitely in the server room in building A.
So these switches don't connect directly to the routers.
These switches are connected to some of these switches in distribution. So this is your physical connection switches, and this is a Wi-Fi switch. This is a Wi-Fi switch. So these Wi-Fi switches are connected to the distribution layer switches. And maybe these distribution layer switches may be located in this building itself. I'm not sure. We need to go and check the management room or the mechanical room we have in this building. Okay, we will try to invite, I'll talk to someone in the IT if they can come and explain a little bit more about the type of network type design they have in this building. But I'm not sure, because they may not want to reveal everything. Okay, so advantage of, what is an advantage of this design is that the traffic designed for nearby nodes can be handled differently and more efficiently than the traffic that must traverse longer path to the destination. So just imagine a computer which is connected to the same switch, or a computer which is connected to this switch. So how this network traffic flows in this case? How the network traffic flows? If you want to send a message to this computer, so the message goes to this switch and go back to this computer. If you want to send a message to this switch, then message goes to this switch identifies that this computer does not connect it to my network, so it will send a message to either this switch or to this switch, and then it goes this computer. It never goes to this core because it belongs to the same network. But if you are trying to go to the Google, if you are trying to access the Google, then it will definitely go all the way to the core switch and get out of the network and then comes back. So this type of network is basically reducing the overwork or reducing the redundant communication in your network, so that you will get the optimal performance of communication. And it is something like your highways are created so that the traffic which is trying to go longer distance can take the highways and go out. Or you want to go from one house to other house, then you don't need to take the highway. You can take the streets or normal roads to reach to that destination. Okay, so the flow of traffic between peers. Now, what are the peers here? Can you tell me what are the peers here?
The same access layer.
What are these two? They are peers. These two, or all these three, they are peers. These two here, they are peers. These two here, they are peers. So the same type of devices in the same level, they are considered. For example, you all are sitting in this room, are peers to each other. When I go back to my room, my staff room, then my other staff members are my peers. So the flow of traffic between the peers within a network segment is called east-west traffic. Now here, this two words are very important here. Within a network segment. What is that network segment means? See, that's why we need to connect all these dots. In the beginning of the session, I was asking you a few questions, and in that question I asked, what do you know, what is the octet represents, right? So there are some octet represents network, some octet represent host. So when I say network segment, that means I'm talking about same network. Now how can I say it is same network? How can I say it is same network? When I say it is same subnet mask. If all the computers are using same subnet mask, then they are in the same network. Now even then when I say same subnet, even then doesn't mean that they are in the same network, because in some cases the subnet mask creates different network. You need to identify that how these subnets are created. Then only you can identify if they belong to the same subnet or they are the different. For example, if I create a subnet of 32 computers, and every classroom has 30 computers exactly. 30 computers here, 30 computers there, 30 computers in other room, 30 computers in that opposite to this classroom. So can you say that these computers are in the same network? When I'm saying each network can have 32 computers, each network can have 32 computers. So then can you say that more than 30 are in the same network? No, definitely not. If I say there are in one subnet I can have 1024 computers. In one subnet we have 1024 computers, and this building has 800 computers. Then can you imagine or can you understand that all the computers may be in the same network? Possibility. There is a possibility that when all the computers are in the same network. So even if you have the same subnet, in some cases your computers may be in a different subnet or different network. So you need to understand that if my computer belongs to same subnet or same network segment, or they are the part of different network segments. So if they are in the same network segments, then it is called east-west traffic. If the traffic must leave the local segment to reach its destination, is called north-south traffic. Now, you need to understand this one as well. Say this is, let's say, this is your PC, and the IP, like the network we have created before, right? In the packet tracer exercise. And this is the PC 192.168.1.10. They are connected to the two switches, switch 1, switch 2, and they are connected to each other. Let's say they are connected to each other. When I'm discussing a concept, this guy ran out of the class. 172.168.1.1 and 192.168.1.1. Now if you are trying to reach to this computer, even these two switches are connected to each other, you will not be able to reach this computer directly via switches, because these two IP addresses are completely different. So these two switches cannot cannot identify if this switch is connected to this type of network and that switch is connected. So they have to take the path of this through the router. they have to take the path through the router. They cannot go directly. But if I'm having another computer here connected to the same switch using the same series of IP address, then in order to reach to this computer, I can go directly from here to here. I don't need to go all the way to the router because the switch knows, and switch is connected, or this basically belongs to the same subnet or same network segment. So if I'm communicating from here to here, I'm doing east-west communication. This is my east-west communication. If I want to send a message to this computer, what type of is this? It will be north-south. Because you have to leave your network segment to reach to this network segment. So these switches, because they are connected to different networks, so these switches are creating different network segments. But let's change the scenario and make it 172.16.2.10. Okay, 2.10, and the subnet is 255.255.0.0, and same is here, 255.255.0.0. So same subnet, so they are in the same network segment. They are in the same network segment. So now I can send the network messages to these computers without leaving the network segment. Without leaving the network segment, I can communicate to my neighbors, to my peers. So all the traffic here will be considered as east-west traffic. It won't be considered as north-south.
Is that from left to right is east to west, or is it just?
From sorry, come again?
East-west just means it's in the same.
Same subnet.
Okay, same subnet.
If it is in the same subnet, in the same network segment, then it is your east-west traffic. If you are leaving, then it is your north-south. Okay. So now here in this diagram, you can see you have three different layers. So you have a core layer, you have a distribution layer, and you have an access layer. So in this core layer, you can see your switches are connected. So first of all, your access layer, where the switches are, your devices are connected to the switches. So all the communicating devices are connected to the switches, right? Then you have this access layer switches connect to the distribution layer, and you can see it's a mesh. It's a mesh topology. Mesh topology means where all the switches are connected or all the devices are connected to each other in all possible paths. So you can see the crisscross connection. And then you have core layer switches, where these core layer switches are connected to the to each other to provide the redundant paths between the two networks. So by doing this type of network design, you are providing maximum connections to all the communicating devices from one network segment to other network segment. For example, here or here or here, and then you are also getting maximum connectivity options to the internet. Okay. All right, let's take a break here because it seems people are you guys are looking for a break, moving out of the class one after the other. So we stop here and then we will continue from the same slide again.
Yes, sir.